Hey guys, it's Miss Shelley. All right, so after grading our first assignment on scale drawing, I saw that a lot of us were still struggling with how to do it. A lot of you got 50s because you got more than half of the problems wrong. So, what I'm going to do is if you got a 50, I want you to send me a message and we can set up a video chat session where we go over a couple problems. Once you do that, then I will let you redo the assignment and submit it to get a better grade. Okay, so please take this opportunity and use it. So today we're going to start by doing a little reviewing over scale drawing, and then I'm going to have you hop back on over to Teams and you're going to complete an assignment within Teams. So let's go ahead and look at some examples. The first one I want to look at is Ramona. Ramona is asked to draw a tree using a scale of 1 inch to 3 meters. She draws a 4-inch tree. How tall is the tree? So it wants to find the actual height of the tree. So the first thing that we need to do is we need to set up our proportions using our ratios. So we have our model ratio, which is drawing distance, 1 inch, and actual distance, which is 3 meters. So let's set this up. So 1 inch over 3 meters, that's our model ratio. And our real world ratio is our drawing distance, which it says right here, she draws a 4-inch tree. So 4 inches, and it wants to know what our actual distance is. So since we don't know what that is, we're going to use X as our variable, and it's going to be meters. Now, take a close look. Do you see how we have inches in the numerator? Then that means inches needs to be in the numerator for the real world. I have meters in the denominator for model, so meters is going to be in the denominator for the real world. If you can get that, if you get that your scale 1 inch to 3 meters, inches over meters, then all you have to do is plug in the numbers that go with inches and the numbers that go with meters into this equation. It is always going to be the same proportion. Model equals real world, drawing distance over actual distance. Okay, so once we do that, now we can start cross multiplying. So we're going to cross multiply. That's going to be 1 times x equals 4 times 3. 1 times x is 1x or just x, and 4 times 3 is 12. Now, what was that missing unit of measure that I needed? Well, it's right there. It's meters. So the tree that Ramona drew was 12 meters tall. And that's it, guys. Don't make it more complicated than it has to be, okay? This isn't meant to confuse you or be hard. All you're doing is you're plugging your numbers in to your proportion. Your proportion's never going to change. It is always going to be the same, okay? Let's take a look at another example. So I have Tim. Tim was asked to draw a building using the scale 1 inch to 150 feet. The actual height of the building is 750 feet. Before I even deal with that last sentence, the actual height, let's set up my model purport ratio, okay? So that's the drawing distance. The drawing distance always comes first, okay? So my drawing distance is 1 inch, and my actual distance always comes next, 150 feet. So remember, what that tells me is on my scale drawing, for every 1 inch on the drawing, in the real world, it's actually 150 feet. I'm sorry, I wrote meters, but it's supposed to be feet. Okay, so now I can set up my real world. Now it tells me the actual height is 750 feet. So the actual height, that's the denominator. So that goes in the bottom. So 750 feet. Now it doesn't tell me what the drawing distance is. That's what I'm looking for. Since that's what I'm looking for and I don't know, I'm going to put an X. Okay, because that's my unknown variable. It's what I don't know. So now what I can do is now I'm going to cross multiply. So when I cross multiply, that's 1 times 750 equals x times 150. 50. So now I'm just going to multiply. Oh, I put 1, but that should be x. Sorry, guys. So 1 times 750 is 750. And I'm just going to leave my x times 150. Now, I have this problem. I need it to be x equals an answer. However, right now it's x times 150 equals 750. That's not what I need. I need x all by itself. This goes back to our last topic. What operation am I doing to x? I'm multiplying. What's the inverse or the opposite of multiplying? Dividing. So that means that I need to divide that number that I'm multiplying by x. That 150, I need to divide on both sides. So I'm going to divide 150 on both sides. 150 divided by 150, that's 1. Any number divided by itself is 1. So finally now I have x equals. So now I need to divide 150 into 750. Okay, well how many times does 150 go into 7? 0. How many times does 150 go into 75? 0. So now I need to come and guess. I always, guys, whenever I do this and I have to guess, I always start in the middle. Start at 5. 5 times 0 is 0. 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Look, and the very first time I got lucky, I guessed the right number. So that gives me 5. So 5 times 150 is 750. That gives me no remainders. So that means that x is equal to 5 inches. So on this scale drawing, what this means is that on the scale drawing, this building is only 5 inches long. But in the real world, it is actually 750 feet. Could you imagine a sheet of paper that was 750 feet long? No, that would just be insane, unheard of. That's why we have scale drawing, so we can draw these huge buildings on a smaller scale so we can look at them. Okay, so now a lot of us got really confused when we added area to this. We're not doing anything different here, okay? When we are talking about these area problems, all we're doing is we're going to do 2 different sets of our scale drawings. Okay, we're going to do 2 different sets, and then we're going to just plug those numbers into our area formula. We know area. We've been doing area since elementary school, so we can do this. So let's first start and let's find our length. So this is our length, this is our width. So let's set up our proportions, okay? Our first ratio, our model. Our drawing distance is right here, 1 centimeter. And our actual distance is 20 meters. So that'll go in our denominator. So now I can set up my real world ratio. My drawing distance right here, 7 centimeters. And that means that I don't know what my actual length is, so I'm going to put an x. Okay, so now what I'm going to do is cross multiply. 1 times x equals 7 times 20. 1 times x is 1x, or just x. 7 times 20, all I need to do that, I can do that easily in my head. 7 times 2 is 14, and add that 0 at the end. So the actual length of my garden is 140 meters. I'm going to do the same thing for width now, okay? So when I'm doing these area problems, I'm not doing anything else. I'm doing more work, but I'm not doing anything different. So now I can set up my ratio for my model. Same ratio that I used for length, 1 centimeter over 20 meters. And now I can set up my real world ratio. So my drawing distance, it tells me right here, is 2.75 centimeters. And my actual distance, that's my unknown, my x, my variable. That's what I'm trying to find out. So now I'm just going to cross multiply again. So that's 1 times x equals 2.75 times 20. 1 times x is 1x, or x. And now I can come over here and I can do 2.75 times 20. 0 times 5 is 0, 0 times 7 is 0, 0 times 2 is 0. Done with the 0, put your placeholder. 2 times 5 is 10, carry your 1. 2 times 4 is 2 times 7 is 14, plus 1 is 15. Carry your 1. 2 times 2 is 4, plus 1 is 5. Add it all up. That gives me 0, 0, 5, 5. Now remember, when you multiply with decimals, you line your numbers up like normal, and you count the places after the decimals. There's 2 places there, 0 places there. So I have a total of 2 decimal places. So I put my decimal in the back, the end, and I move it 1, 2 times. So that means that the actual width of the garden is 55 meters. You cannot stop here. You have to find the area. Guys, this is easy, okay? Don't get like, oh, I can't do it, because you can, okay? Remember, all area is area equals length times width. So all you have to do is substitute your numbers or plug them in. So the length that I found was 140 meters, and the width that I found was 55 meters. So I'm going to come over here and I'm going to do 140 times 55. 5 times 0 is 5. 5 times 4 is 20. Carry that 2. 5 times 1 is 5, plus 2 is 7. Cross that out. Put my placeholder. 5 times 0, oh, cross that 2 out too. We don't need it. 5 times 0 is 0. 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 2 is 7. So add that all up. I get 0, 0, 7, 7. There's no decimals. So that means that my area equals 7,700. Now remember, you have meter times meter. You have 2 meters, so that's going to be meters squared. And that's my final answer. So my final answer is 7,700 meters squared. Okay? You can do this, guys. I promise. You just have to remember your proportions, plugging your numbers in. That's all you're doing, okay? You're remembering your proportions, you're plugging your numbers into those proportions, and you're multiplying, dividing if needed, and then you take your length and your width and you put it in your area formula. Okay? That's it. The hardest thing you do is if you have a problem that has a one-step equation or decimals. Okay, so let's take a look at one final. So I have this scale drawing. You'll see the scale drawing again in your practice. It says a scale drawing of a house is shown below. The scale is 1 inch equals 30 feet. What is the area of the bedroom? Okay, so it tells me down here the width of my bedroom is 3 inches and the length is 4 inches. So the first thing I'm going to do is I'm going to do my length. So I'm going to set my proportions up. For my length, I have my model ratio, which is the drawing distance. That's my first number, 1 inch, over my actual distance, my second number, 30 feet, equals. Now I need my real world ratio. Now it's in inches, so this is the drawing distance. So my length is 4 inches, and I'm looking for my actual distance. So that's going to be x feet. Now that I've done this, I just need to cross multiply. So 1 times x equals 4 times 30. 1 times x is 1x, or x. Remember, it has a 0 at the end, so all I need to do is multiply 3 and 4, which is 12, and add that 0. So the actual length of my bedroom is 120 feet. I'm going to do the same exact thing I just did for length. I'm going to do it again for width. So setting up my model ratio, that is 1 inch over 30 feet, equals. Now the width of this, the drawing distance, is actually 3 inches, And remember, I don't know what the actual distance is, so that's my variable x. So I'm going to cross multiply. So that's 1 times x equals 3 times 30. So now I'm just going to multiply. 1 times x is 1x, or x. 3 times 30, well, 3 times 3 is 9, and add my 0, so that's 90 feet. Now, just going to take those numbers and substitute them into my formula. My formula is area equals length times width. And that's it, guys. So area equals my length, which is 120 feet, times my width, which is 90 feet. So I'm going to come over here off to the side. I'm going to do 120 times 9 times 90. And I'm going to show you a shortcut after I do this. So 0 times 0 is 0, 0 times 2 is 0, 0 times 1 is 0. Cross that out, put my placeholder. 9 times 0 is 0, 9 times 2 is 18, carry the 1. 9 times 1 is 9, plus 1 is 10. Add that all up, that gives you 0, 0, 8, 0, 1. So my area equals 10,800. Now I have feet times feet, so remember that is feet squared. Something else you could have done is you could have just done 12 times 9, which we know is 108, and then counted your zeros, 1, 2, and then added that number of zeros after your 108. Same answer, just using mental math. All right, guys, so that is all you're doing, okay? You can do this. If it helps, I recommend setting up, put model equals real world, and then fill it in, okay? If it helps you to do that, I highly recommend doing that until you get in the habit of doing it. You can do this. Remember, if you got a 50 on your assignment, please message me so we can set up that video chat session so you can redo that assignment and get a better grade. All right, guys, most importantly, always remember, I miss you so